Welcome to Module 4, Data Visualization with Matplotlib and Seaborn. These visualization skills are critical to understanding patterns, spotting outliers, and communicating results effectively, transforming raw numbers into compelling visual stories. This course is brought to you by the Series of Thoughts Tech team. Visualization is your first line of defense against bad data and flawed assumptions. It reveals patterns that summary statistics often miss, helping to identify outliers that could skew your models. Your visualization toolkit consists primarily of Matplotlib, the foundational plotting library, and Seaborn, which is built on Matplotlib and provides beautiful statistical visualizations with less code. Both integrate seamlessly with NumPy and Pandas. To get started, we import Matplotlib as PLT, Seaborn as SNS, along with NumPy and Pandas. We can also set a default figure size and optionally apply a Seaborn style like white grid for better aesthetics. Line plots are ideal for visualizing trends over time, such as stock prices or temperature. Here, we plot a sine wave using plt.plot. Remember to label your axes and add a title for clarity. Scatter plots help explore relationships between two continuous variables. Each point represents an observation, revealing correlations, clusters, and outliers. For example, we can examine if age predicts salary. Bar plots are perfect for comparing quantities across distinct categories, making differences immediately obvious. The height of each bar encodes the value, which is great for displaying counts or ranking items. Histograms show the distribution of a single continuous variable by grouping values into bins. This reveals the shape of your data, helping you determine if it is normal, skewed, or bimodal. The Matplotlib figure has a specific anatomy. The figure is the entire canvas, the axis is the actual plot area, the axis contains the number lines and labels, and artists are all the elements drawn on the plot. You can customize your plots using colors, line styles, and markers. Always label your axes and add descriptive titles. Customization allows you to encode information and improve readability. To save your figures for reports, use plt.savefig, specifying parameters like dpi and bbox_inches equals tight. Always save before calling PLT show. Vector formats like PDF or SVG are ideal for professional publication. Subplots allow you to compare multiple visualizations side by side in a single figure. Using plt.subplots, you can create a grid, such as 2x2, which is essential for comprehensive exploratory analysis. When building a subplot grid, you index individual plots using row and column notation, then use set_title and set_x label on those specific axes. Use plt_tight_layout to prevent label overlap. Seaborn is a higher-level library built on Matplotlib. It focuses on statistical visualization, providing beautiful defaults and powerful functions perfect for exploratory data analysis with minimal code. You can set the overall style of your Seaborn plots using sns.set_style, choosing from options like white grid or dark grid. You can also set color palettes, selecting colorblind safe options for accessibility. Seaborn's histplot function is used for distribution plots. Setting KDE equals true adds a kernel density estimate, a smooth curve that shows the probability density, helping to compare distributions effectively. Box plots visualize statistical summaries, revealing the median, spread, skewness, and outliers in your data at a glance. They are ideal for comparing distributions across different categories. Seaborn's scatterplot function enhances basic scatter plots. The hue parameter allows you to color points based on a third categorical variable, revealing hidden patterns or relationships. Pair plots create a matrix of scatter plots for every combination of numeric variables in your dataset. This powerful tool is essential for exploratory analysis, helping you spot correlations and clusters across all features. Correlation heat maps visualize feature relationships. The colors encode correlation strength, from -1 to +1. Setting a not equals true prints the correlation coefficients in each cell. Count plots are specialized bar plots for categorical data, showing the frequency of each category. They are crucial for understanding class balance. Remember to rotate x-axis labels if category names are long. Choosing the right plot type is essential. Use line plots for trends, scatter plots for relationships, bar plots for comparing categories, and histograms for understanding distributions. Seaborn offers 3 main palette types: categorical for distinct groups, sequential for ordered data, and diverging for data with a meaningful center point like 0. Before building machine learning models, visualize feature distributions using histograms or KDE plots. Look for extreme skewness, unusual outliers, and multimodal shapes, as these issues require attention. Correlation analysis helps with feature selection. Highly correlated features are redundant. Use heat maps to find pairs above 0.8 or 0.9, but remember that correlation only measures linear relationships and doesn't imply causation. In classification problems, visualizing class distribution with a count plot is critical. Heavy class imbalance requires special handling, as most algorithms assume balanced classes. Learning curves plot model performance against training size. They help diagnose if your model is underfitting or overfitting by observing whether training and validation scores are converging. A confusion matrix shows classification results in a grid, with rows as actual classes and columns as predicted classes. Visualizing this as a heat map reveals which classes your model is confusing. For best practices, always label everything clearly, choose the appropriate plot type for your data, use color purposefully to encode information, keep your plots simple, and consider your audience. Avoid common mistakes such as truncating the y-axis on bar charts, using too many categories, relying on 3D charts, and using misleading color palettes for your data type. An exploratory data analysis, or EDA, report systematically explores your dataset. Key steps include visualizing distributions, exploring relationships, analyzing the target variable, and documenting all insights. Your assignment is to create a comprehensive EDA report using Matplotlib and Seaborn, incorporating at least 8 different visualization types. You should tell a clear story about the data in a Jupyter notebook. Recommended datasets for practice include the Titanic dataset for classification, the IRIS dataset for relationship exploration, and the California housing dataset for distribution analysis. Key takeaways: visualization is essential. Master both Matplotlib for control and Seaborn for statistical plots. Match the plot to its purpose. And finally, practice to make the process intuitive. You now have the visualization skills to deeply understand your data. These skills form the foundation for what's next: building actual machine learning models. Keep these skills sharp, as every great data scientist is also a great storyteller.